In the previous video in this series, I got as far as getting my Osborne OCC1 vintage computer to try accessing the boot drive. So normally to boot this up, you power it up, you'll get a message on the screen telling you to put the disk into drive A. You put your boot disk in, hit the return key, and it should start booting from floppy disk. So the boot process is a two-step process. It will start by reading a bootloader from the first few tracks of the floppy disk. It will load that into RAM. It will then hand control to that bootloader, which will then load CPM or whatever you're booting to from the floppy disk, copy it into RAM, and then ultimately it will hand control to the operating system that you've just loaded. So that's the process that it should go through. I haven't tried this yet, so what I want to do now is put a floppy disk. I'll just duplicate what we did in the previous video and show you how far it gets. I've got the keyboard plugged in now. I've been through this, one key left to fix. I've actually repaired the membrane. I'm just leaving it. I'll leave it for 24 hours once I've done it to make sure I don't push the hump back down again. If you want to see what I was doing with this, then you can go back and look at one of the previous videos. But I don't want to put the key back in too soon, which is why it's not there yet. Okay, so we'll get this powered up. So we have the short startup beep. Just waiting for the screen to come up. You are going to see some flickering on the screen, I should think. Just looking through the camera viewfinder, but that's not evident in real life. If you've seen flickering, it's normally in real life. It's normally because at least one key is held down, and there's a key stroke buffer, and it's going through trying to process the key, and it causes the display to blank while it's doing that, and it makes it flicker. If it's flickering continuously with the keyboard plugged in, chances are you've got an issue with the keyboard or the interface electronics. So what we can do now is try booting from floppy disk. Now there isn't a disk in either drive, but it should still, it doesn't check it first, it just tries to read the disk. So you should see the disk light come on, and then we'll get an error message on the screen. It's upside down of course, but you can still see that it's doing something on the screen. So we'll try hitting the return key. So notice that the drive lights come on. You can hear it clunking away. It's going to track 0, trying to read the first track of the bootloader, or the first sector of the bootloader. It's failing and coming up with a boot error, which is kind of a good sign. It means at least the system is running to a large extent. So we'll press reset to stop that. Now unfortunately with this machine, I was reading through the technical documentation, and there is, although there's a monitor program which is responsible for what we've just done in effect and putting this message on the screen, there's no built-in ability to read and write to RAM or anything like that. So there's no built-in way of testing this, and the reason it gave in the technical manual was because all that's available on a floppy disk, which I thought was kind of a bizarre thing to write. Generally speaking, if you can load something from a floppy disk on a machine like this, then it's 95% functional. The time you need the inbuilt monitor test programs is when you can't do that, so it does make these quite tricky to work on. But having said that, we'll proceed. I'm hoping it's going to boot from floppy disk, but I kind of suspect it won't. There's a lot of corrosion on the underside of the daughter board, and I've got a feeling that might be causing a few issues. Okay, so it accesses drive A when we try and boot from it. We'll try and boot from drive B and see if it can access that one as well. And so as we can see, it's trying to boot from drive B, coming up with the same boot error because again there's no disk in there. So we'll stop that, and we'll try and do the same thing now with a disk in the drive. This is not a boot disk, I don't want to put, I want to get one boot disk, I don't want to put that in just yet. I want to see if the system does anything different with the disk in. It's normally it's going to read something and it will respond slightly differently to the way it was responding before. And I don't know if you can hear that, it is now cycling much more quickly. So in other words, it does make a difference having a disk in there, which means it is probably reading the sector, realizing it's the wrong data, and then trying again and throwing up the error message, which is a good thing. It means it's probably reading the data. We'll have a look at that with the scope in a minute. We'll try the same thing in the second drive. Just trying to reach around the camera doing this, so if you want to mind being a bit cack-handed. Okay, so we'll try now booting from drive B. Exactly the same thing, same sort of timing, so that's a good sign. It means it probably is reading from both disks. Let's stop that again. Okay, so that's a good sign. It means that the chances are we are reading from the floppy disk. I'll put this back into this drive and we'll put a scope on the data line and just see if something is actually coming out. So we'll try monitoring the data line while the disk is trying to, or the machine's trying to read the disk. And you can see there is data coming out, and not only that, it looks to be fairly good, consistent data. And on top of that, it stops when we hold the disk. So that's a good sign. It means almost certainly the machine is reading data. Whether it's reading it correctly is another issue, but usually you can tell looking at the data coming out if it's just reading garbage, because it will look like kind of just messy data. Okay, so I'm fairly confident now that we can put an actual boot disk in this and see what the machine will do. Okay, so I want to get one boot disk. Unfortunately, I don't know if this works. I don't know if the disk itself is a good disk, but we'll try and put this in. So fingers crossed, we'll try and boot. Okay, that's different. Well, it hasn't booted, but it's obviously done something. So it seems to have gone to the first track, and I heard it go from, after a few seconds, go from the first track and step onto the second track, but then it's kind of done nothing else. So we'll try that one more time. We'll reset the machine. So yeah, it's going to track 0, reading something. It must like what it reads, otherwise it would throw up an error message. It's then going to the next track, then after a few seconds it's stopping. I suspect it's loading up the first stage bootloader, handing control to it and then crashing, because the machine is now not responding, whereas if it was still functional, we'd get this flickering on the screen. Let you actually see it, but it's now flickering. But if I try and boot it, let it go through the process, it's doing exactly the same thing every time as well. Okay, and now it's non-responsive. So I suspect the machine's crashed when it's handed control to the bootloader. That might be just a RAM error. It could be we've got an issue with the RAM on this machine, which is a bit of a pain. I'll come to that in a few minutes as to why it's a pain on these. I'm not going to move the disk into drive B, and we'll try and boot from drive B and see if it does exactly the same thing. Just really trying to eliminate any specific faults. Now it could of course be that both drives are faulty. Okay, I've got the disk in drive B. I've reset the machine. We'll try and boot. Did exactly the same thing. I heard it drive to track 0. After a few seconds I heard it step on to the next track, and a few seconds later it stopped. There's no boot error message, So I suspect the machine's crashing when it's trying to hand control to the bootloader. The usual cause of that is faulty RAM. So what I'm going to do now is turn the board up so you can see it, and I'll explain why looking for faulty RAM on this is such a pain. On most machines of this era it would be fairly simple now to test the RAM, but on this machine it really is a pain to try and do that. I've got the board flipped up so you can see the component side, and when these were originally made, the first version just had this large board and you could access all the components on it. Unfortunately, as the designers added new features, they kind of sandwiched everything on top, but they did it in such a way that it makes it almost impossible to work on sensibly. It's kind of a contrivance really, the way this is done, and it causes some other issues. Now the first thing is this board is effectively glued in, and this is the high density or double density board, interface board for the floppy disk, and the way this is held in, it's actually glued in. There's a socket down here that plugs into the original socket, so you need to remove the board by pulling it directly upwards, but you can't do that because these plastic supports are glued to the main board. So what you have to do with this really is slice these off very close, so there's just a small overhang, just enough so you can kind of ease a little tab back and then unplug the board. You need to get this board out to get to the RAM chips, because they're on the main board underneath this. So they've kind of glued a board over the top of the parts that are most likely to fail. Same with this board. This part of this board sits over some of the RAM chips, and also this is called a screen pack. It's really so that you can use an external monitor, and it also expands the capability of the text output, the graphics output of this machine. But again, this, you can't run the machine if you just simply unplug this. So what they did is there are three interconnections between this board and the main board. There's one over here that takes connections from the original display output connector and brings it through onto this new board. There's another one that sits underneath and plugs into the original ROM socket, and then there's the main problem, which is the CPU socket. So they took the CPU out and then put some extend pins on the underside of this new CPU socket. The CPU plugs into this top board, and then the extension pins go down and plug into the original socket. Now the problem is, firstly, you can't obviously take this off and run the board at the same time, and if you try and make an extension lead, it probably won't work because of the effect that the lead has on the signals going to the CPU. I did try it once, and it kind of half worked and kept crashing, and it caused more problems than finding an alternate solution. But the main issue is that the extension pins that they use damage the original socket. They splay the pins out on it, so when you try and plug an IC into the original socket, it doesn't make proper contact anymore, and the system will crash. Generally speaking, when these systems don't run, you'll get a continuous tone and both drive lights will stay on. And that's what it does if you try and do that. Because the easiest solution would of course be to remove these two boards and put the original version 1.3 firmware in it, along with a copy of the original character ROM, and then run it as a 1.3 board and test it that way. But unfortunately that's quite difficult to do because of the damage that fitting this board does. That might be an option, that might be something we have to do. Unfortunately I can't find any copies of the 1.3 ROM firmware. If you have a copy of it that you'd be willing to send me, then please let me know. That would be an option for one method of testing this. Another option that would be nice would be to plug the fluke into this, and then we could analyse the RAM that way. It's a bit tricky on these. I haven't actually found a sensible way on these to switch memory banks. There are 3 memory banks on this. The first bank is RAM. The ROM is in the second memory bank. Now, unfortunately, when this machine resets, it switches to memory bank 2, which is where the ROM resides. Not this ROM, it's the ROM that sits underneath this board, so that it can start the monitor program and initialize the machine. So it starts up in bank 2, and the RAM that we want to look at is in bank 1. So using the flute, we need to find some way to switch the banks. It will be possible, I just haven't found a way of doing that yet. So that would be the other option. So because of the fact I can't really get to any of this without starting to modify it and take it apart, what I'm going to do is actually attach the logic analyzer to the CPU, and we'll start trying to look and see how far through the boot process it's getting by looking at the data we can capture and see how that correlates with the code that we can see in the documentation that's available. Luckily, the documentation does include the code and the firmware listing for the main ROM, so we can compare that with what we can capture on the logic analyzer and try and see how far through the boot process it's getting and try and get some idea as to where it's crashing. Like I said, it would be nice just to test the RAM, but that's actually quite difficult on this machine with these option boards fitted. Okay, I'll get the analyzer set up, and we'll start trying to look into this and see if we can capture any sensible data. I've got the logic analyzer connected up. It's a Z80 processor, of course. I've just got it set up to monitor a Z80. I'm not looking at anything else at this point. It might be possible to look at the RAM bus and try and figure out what's going on with the RAM, but we'll look at that later. The first thing I want to do is try and get some idea as to where in the boot process it's failing. So if you look at the listing, I won't show you the listing now. It's not a particularly big ROM on this. There's not a huge amount, and what I've got the logic analyzer set to do is trigger on the successful read of the first track of the floppy disks. That is, it will read the floppy disk when we try and boot, in theory, and if it is reading it and it's happy with what it reads, then it should move on to the next track. But I've got the analyzer set to trigger on the successful read of the first track. So I'll move the camera so you can see the logic analyzer screen, and we'll give it a run and see what happens. I'm using my Agilent 1680 AD logic analyzer for this. I've got it set up for a Z80, all the pins are connected, and I've actually got the trigger set to an address of 02A2, and that's a hex address, and that is the entry point for in the code where it has read the first track from the floppy disk, and it's happy that what it's seen is correct. And so if it gets to this point, it means that it's been able to read the floppy disk, and it's analysed what it's read, and it's happy with what it sees. So we'll arm the analyzer. I'm now going to press the return key on the keyboard of the Osborne. You can hear the drive start up, and the analyzer has indeed been triggered. So what I can now do is start working my way through the data that it's captured and try and figure out exactly what it's seeing, if it's correct. Looking at the values won't exactly match what are in the listing in the technical documentation, because there is an offset, of course, for the ROM. So any addresses, you need to take that into account, but the other values should be correct. So I'm going to start looking through this, and assuming this looks okay, then all I'm going to do is incrementally go through the various blocks of code in the listing, trying to follow through the boot process and then try and get some idea as to where this is failing. If I can't make any decent progress doing this, then I'll need to remove the two daughter boards from the machine and try and get it to run without them present, because to get to the RAM chips I of course need to remove both of those boards, and I don't want to do that 32 times, 32 RAM chips of course. The other option is to try and remove the daughter boards, connect the Fluke and see if it will run with the daughter boards removed. I've never tried that on this machine or these machines, so it might be an interesting experiment to see if that works. If you've tried that and it works, then please leave a comment. But at the moment this is the method I'm going to use, and I'll just move the camera back down. So electronically these aren't too difficult to work on, but logistically trying to get to the various parts is a bit of a nightmare on these. Really don't like the way these have been put together. If it was a basic machine without the daughter boards, it would be quite nice to work on, but configured like this, they are a real pain. So they're not irreparable, it's just difficult and time consuming, much more so than it would be normally. But as I say, I suspect the issue is going to be with the RAM. Now it could of course be any of the glue chips that control that, but it'll be interesting to try and find out what's going on with this and see if we can get it to successfully boot. Now it could of course also be a faulty floppy disk, and it might be that the disk isn't right and what it's reading and writing to the RAM for the bootloader is incorrect. I'd be surprised if that's the case. I would expect it to throw up an error before it gets that far, but depends on the nature of the issue. But as I say, I suspect it's a RAM fault. It'll be interesting to find out where this leads, and in the next video we'll look at ways of testing the RAM.